So, good evening. Welcome to the 8th week of the live interaction session for the course Multimodal Urban Transportation Systems. The instructor is Professor Arkopal Goswami and I am Shankhadeep Pramanik from IIT Kharagpur. So, we'll just first we will give a brief recap of what has been taught in this week and then we shall proceed to the question answers. So in this week we were discussing about non-motorized transportation planning as different planning aspects, and first we discussed about the 10 guiding principle and the 6 supportive principles of planning the transport system of a city. Then in the next we discussed about different sidewalks and footpath, and also how to design this sidewalk or footpath for a particular level of service. These things were discussed, and then we discussed about the crosswalk and mid blocks, that how to design and what should be the width, or how much should be the minimum gap required for the pedestrians to cross a particular streets. These things were discussed, and then we moved to the cycle mode, bicycle, and we discussed about how different facilities can be designed, bicycle facilities can be designed integrating with the available right of way, and where like keeping in mind the complete street structure, how we can design the bicycle facility, also how the level of service and the other different aspects like side distances, and from the safety aspect, how we should design a intersection which may be useful for bicycle riders. These things were discussed, and uh, mm, now this also based on different IRCs like IRC 2015, or in the case of the pedestrian facilities, this IRC 103 2012. These were followed during the lectures. So moving forward, the first question is: the following figure is an example of which of the following NMT guidance principle? Interconnected NMT network, walkability, universal accessibility, protection from encroachment. So you can post your answers in the chat box. The picture is basically showing that the old people are accessing this footpath facility. So it is universal accessibility. C will be the correct answer. So we learned about 10 principles of NMT guidance document. As per NMT guidance document, there are different aspects like complete street, bicycle, walkability, comfort or safety. These things we should remember while designing a particular NMT system. So there one of the major aspect is universal accessibility, that it should facilitate older people or disabled people, everyone, so that it should be barrier free movement for all type of NMT users. In some cases the footpaths are in the level of the road, so that the people will with wheelchair also they can easily enter uh, in this path. And also there are tactile pavements, this one, so it will help the blind people to navigate into the footpath. So this is basically a picture of universal accessibility. Next is, what are the advantage of interconnected NMT network? Reduction, reduce congestion, encourage use of NMT modes, reduce walking distance, all of the above. Mm, yes, of a interconnected is where the different there is a connection between different roadways. So an interconnected NMT network reduce congestion. It also encourage the use of NMT modes and reduce walking distance between places, as well as it saves time. So all the above answers are correct. Next is, which of the following statements is true for NMT wayfinding? It promote NMT usage among tourists. It providing easy and legible navigation, provides uninterrupted non-motorized mobility, and brings in a sense of order, assist the users in navigation, and improve sense of place. It is true. Yeah, it is the true. Which of the following statement is true for NMT wayfinding? So more than one answer can be correct. So NMT wayfinding is basically how people can uh, like how they can find what they want to go, or it is specially useful for tourists who are new to a particular place. They can easily navigate to a particular area. So it is essential to assist the users in navigation and improve the sense of a place, and it provides a easy and legible navigation. Also, because it is easy and legible navigation, so it promotes NMT use among tourists. So these three, it promotes NMT use among tourists, this is correct. Providing easy and legible navigation, it is also correct. Assist the users in navigation and improve the sense of a place, it is also correct. And last one is provide uninterrupted non-motorized mobility and brings in a sense of order. It actually don't have any connection with NMT wayfinding. It is basically connected to protection from encroachment, like this kind of facilities, that it it brings a sense of order and also uninterrupted non-motorized mobility. So vehicles cannot be parked in this area, and there is a protection basically from the encroachment. So this statement is false, and A, B and D are the correct answer here. Next is, which of the following is a NMT supportive principle? So there are 6 NMT supporting principle. So there are 10 actually main guiding principle and 6 supporting principle. Guiding principles are the main thing that needs to be there, and supporting is quite like additionally how it improves or how can be it can be sustained. So say it should be a complete street, it should be a bicycle friendly, walkability should be good, comfort and safety is one of the important aspect, safety and security. Also NMT wayfinding is also required for developing a particular non-motorized transportation system, and also protection of encroachment is very much essential. And supporting principle is like additionally it is what it is doing, like it supports the informal sector, it supports mixed use of a particular place. It also transit priority or parking management, build cycling culture. These things also additionally can be grown with this in a non-motorized transportation planning. But main while planning we have to keep in mind these 10 aspects, and additional these 6 aspects will also come later or maybe at a secondary stage. So it is supporting principles. Therefore here safety is very much important, walkability is also important for as we are talking about non-motorized transportation. So there should be a good walking space. Also people have to find where they the locations where the locations are located, so that comes under NMT wayfinding. And transit priority is the additional thing that may come with non-motorized transportation. So D will be the answer here, transit priority, like a priority for a particular system, bus or any other, maybe cycle, priority for that may come in a later stage. But the safety, walkability these security, these kind of uh, factors should come first. So option D will be the correct answer. Next is a 2-meter wide footpath with no obstructions in a commercial area with a wall on one side and barricade by guardrail on other side has a peak flow rate of 2100 pedestrians per 15 minutes. Estimate the present pedestrian level of service. What will be the widening requirement to maintain the service quality at PLOS C? Consider the maximum flow rate possible at PLOS C. Use the pedestrian LOS standard and shy away distance as defined in Indo HCM 2016. So these are basically the shy away distance, and these are different level of service. So you need to find the what will be the level of service and what will be the widening requirement to maintain the service quality at PLOS C. I'm giving some time, then I will discuss. And while calculating the shy away distance, one side is wall is one side and guardrail is one other side. So the value for shy away distance is 0.4 to 0.6. So we can take a middle value of 0.5 for both the case, this one as well as this one. So footpath width is given as 2 meter, and in this table we have to calculate the first we have to estimate the present pedestrian level of service, and how we will do it from this table. And in this table, for different location, the some values are given, uh, and in this case it is for commercial area, so we will consider this one. Now in what unit these values are given, it is basically pedestrian per minute per meter. In that way we represent the these values. So from this question we need to calculate a value that is in the pedestrian per minute per meter, and we have the in the question it is given that peak flow rate is 2100 pedestrians per 15 minute. So if we convert it uh, to 21, pedestrian flow is 2100 per 15 minute, so it will be 140 per minute. So 140 pedestrian per minute, this one we got. Now what will be per meter, pedestrian per minute per meter? For that we need to calculate the effective width of the footpath. So people will go mainly this in that portion, with maybe maintaining a certain gap that is known as the shy away distance. That gap they will maintain from the edge of the footpath, and in this case one side is wall and one side is barricaded by guardrail, and in both the case we have taken the value of shy away distance as 0.5 meter. So from both sides we will deduct 0.5 meter, so the effective width will be 1 meter only. So we know the pedestrian flow per minute, that is 140 per minute, and we also know the effective width of the footpath, that is 1 meter. So pedestrian flow rate will be pedestrian flow per minute by effective width, so it will come as 140 per minute per meter. And if we come to this table, for the commercial area it is greater than maybe 69, so it will come under LOS F. So it will be LOS F. Now the second question is what will be the widening requirement to maintain the service quality at PLOS-C. So we have to maintain under this service. Now to maintain level of C, flow rate should be greater than 19 to 30 pedestrian per minute, and let us consider the maximum flow rate possible. So let's consider this maximum one, that is 30, and minimum effective walkway width to maintain 200 pedestrians per 15 minute, that is 140 pedestrian per minute, will be pedestrian volume per minute divided by the flow rate. So it will come as 4.6. Now it is the effective width through which pedestrians will flow. So total width of the footpath will be required 4.6 plus 1 meter shy away distance. This distance is this shy away distance. So total 5.6 meter width of the footpath is required to maintain level of service C. But we have already 2 meter of the footpath, so 5.6 minus 2, that is the 3.6 meter extra widening required for the footpath. So we first need to calculate the present level of service, while calculating present level of service, we calculate first the pedestrian flow per minute, then we calculate the pedestrian flow rate, that is pedestrian flow rate per minute by effective width. So it will come 140 pedestrian per minute per meter. Now in the question it has asked to maintain a level of service C. So for maintaining level of service C, the pedestrian flow rate should be between 19 to 30, and if we consider the higher side, so 30 pedestrian per meter per minute. Now for that we know that pedestrian per minute, 140 pedestrians are going per minute, this one we know, and we know that our flow rate should be 30 pedestrian per minute per meter per minute, so that the level of service maintained at a level of service C, and for that we required 4.6 meter width. So total and this width is the effective width, so total considering the shy away distance, the total width will be 5.6 meter, and we already have a 2 meter wide footpath, so we just subtract it, the 2 meter, so it will come as 3.6 meter. So option B will be the correct answer here. Present level of service is F and extra widening required is 3.6 meter. Next question, which of the following property entrance are considered proper design? Both 1 and 2, 1 and 3, 1 or 3. Yes, the correct answer will be option D, 3, this one. So in the first case there is a abrupt ending, so it will be difficult for the handicaps or disabled people or old people to access this footpath, so this abrupt ending is not desirable. Then in the second case, the lowering of the entire footpath to the level of the carriageway is unacceptable, as property entrance may become waterlogged. So this, as this portion is in a downgrade, so this will be waterlogged. And third is where required to provide the access to private properties, vehicle ramp should be provided in this zone, so the vehicles which are coming, they can go with this ramp, and the people who are moving through, they can just pass from here to here, so their path may is not disrupting. So this one is the ideal design. So option 3. Next is, as per IRC 103/2012, what should be the minimum clear width of a pedestrian access route exclusive of the curb? So in IRC 103, this minimum clear width value for pedestrian access route is given as 1220 mm exclusive of the width of the curb. So this option C is correct here. You may not require to remember these all values, but this is the minimum value, that's why it may be asked in sometimes. As per 103/2012, the height of the footpath should not be more than 150, 160, 170, 180 mm. So, right, it will be not more than 150 mm. In the while designing the stairs also, we sometimes take this 150 mm value, otherwise people will feel discomfort. So this minimum height of the footpath should be not more than 150 mm. In the following figure, this A denotes tactile paving, ladder pattern, desired line, none of the above. Yes, it is the desired line that people generally tend to cross in a shorter distance. So this is the desired line, and this tactile pavement is this one, which is helpful for the blind people maybe to way for their wayfinding. And this ladder pattern is in some busy intersection, these kind of patterns are generally provided, which is known as ladder pattern. Next is calculate time gap for a platoon of 45 school children, 5 in a row, where consecutive time is 3 seconds, width of crossing section is 8 meter, and walking speed of the children is 1.1 meter per second. Assume a startup time as 3 seconds. You need to basically calculate the GS, minimum gap. This is the formula. So this here uh, this n is the number of row. First we will calculate that 45 children, school children are moving 5 in a row, so there are total 9 rows. Now if we consider this formula, w is the width of the crossing, so this one is given as 8 meter, then pedestrian speed is given as 1.1, then uh, TC, which is the consecutive time between two pedestrian. This one consecutive time between two pedestrian is given as 3 seconds. It will be 3. Then n is the number of rows, that is 9, and 9 minus 1 here, and TS, it is the startup time, which is given as 3 seconds. So I guess it will come around 27 seconds. So option B will be the correct answer here. Next is, a road 45-meter wide needs a pedestrian crossing with refugee island. It is regularly crossed by a platoon of 35 school children, 7 in a row. These children cross with a consecutive time of 3 seconds, a startup time of 4 seconds, and walking speed of 1 meter per second. To increase the comfort of the pedestrians while crossing, the city officials decided not to set the pedestrian green time of the pedestrian signal beyond 45 seconds. Determine the number of position of the refugee island on the cross section of the road. Keep a special note on the overall delay faced by pedestrians. As the number of refugee island increases, the overall delay, so overall delay also you need to consider, and you have to find that how many number of traffic island at what interval should be there. The formula is similar to the previous this formula, and here the GS value is given as 45, and you need to find the W value. in this question, it is said that to increase the comfort of the pedestrian while crossing, the city official decided not to set the pedestrian green time of the pedestrian signal, that is GS, beyond 45 seconds, and it will also minimize the delay. So in this question, GS is given as 45, and here 35 school children are moving 7 in a row, so n will be 5 row, that is number of row 5. So n is 5 and the consecutive gap is given as 3 seconds. So this one is 3, and startup loss time is given 4 seconds, and speed is also given 1 second. So if you calculate this W, this width we need to find out that with 45 second green time, how long they can go. So it is 29 meter. So W is 29 meter. Now therefore a traffic island is required for the entire width of 45 meter is 45 divided by 29. So the total distance is 45, and at a go they can maximum go up to 29 meter. So after 29 meter they maybe have to stay somewhere, stay in a refugee island, then again they can proceed. So by providing only one refugee island, our condition will be satisfied. So therefore one traffic island can be provided at 22.5 meter interval, that is 45 divided by 2, that is in just in the middle of the total width, such that GS does not cross 45 seconds. So option A1 will be the correct answer here. A1 traffic island is required just at the middle. Next is, what is the design speed generally considered for bicycle facility? 20 to 25, 5 to 15, 0 to 5. You can think like that 0 to 5 kilometer is quite a low speed. Generally people walk in that speed, so 0 to 5 is quite a low speed for the bicycle, design a bicycle facility. And on the other hand, this 20 to 25 kilometer is also quite high, so every bicycle may not go at that high speed. So this one will also not be, also cannot be true, and this one also cannot be true. So it can be this 5 to 15 kilometer per hour. This is quite a reasonable from the context of bicycle speed. So this is the correct answer, 5 to 15 kilometer per hour. Next is, a bicycle is to make a safe turn without skidding at a corner with a turn radius of 20 meter. Determine the maximum speed calculated to 2 decimal place at which the bicycle can turn without skidding. Assume Fs as 0.25, this theta 15 degree, and G is 9.81. So the maximum speed formula is tan theta minus fs. Correct. B is the correct answer here. So for the maximum case, the radius is given. Radius is turn radius is given as 20 meter. This G value is also provided 9.81. Theta is the angle made by the bicycle from the horizontal. It is given as 15 degree and it should not be more than 18 degree, and friction value is also given as 0.25. So it will come as 1.9 meter per second. Next is, which of the following intersection is the most severe type of intersection? Arterial axis, axis, arterial, or distributor axis? So, so in an urban area, mainly the main places are connected with these arterial roads, and from there the branches that are connected, that one is distributor, and all the distributors are also connected with the access road to different houses, uh, or house properties. And the severity of intersection increases when arterial is quite a major type of road. So the severity of uh, different intersection increases with the type of road. So in this case, the most severe type of uh, intersection will be arterial, this one, and the least severe is access to access, because in these arterial roads the speed of the vehicle is sometimes quite high, and the number of vehicles are also quite high, and the width of the road sometimes is more than this distributor or access. So the intersection formed by these two arterial roads are more severe than the intersection formed by different other roads like distributor access or access. So correct option will be arterial, option C. Next is a accept or reject statement. Traffic lights are more safe solution than geometrically designed roundabout. in case of designing intersection for bicycle facilities. Yes, the statement will be rejected because traffic lights are a less safe solution than geometrically designed roundabout or grade separated intersection. So this roundabout or grade separated is the best for bicycle facilities, and then the traffic lights come, because at a green phase maybe there is there is a conflict between bicycle and different other motorized vehicle, but when they are grade separated, then there is a dedicated corridor, dedicated way for them. So traffic lights are the second best in terms of safety. So this statement will be rejected. Next is, a tall building is located 35 meters from the straight line of a car at point C. This one. And 50 meters from the straight line of sight of a bicycle at point A. So bicycle is here at point A and the car is at point C. Now determine the side distance available to the bicycle if the car at C is approaching the unsignalized intersection, which is 100 meters away. So the car is 100 meters away from the intersection at a particular time, and this bicycle is also approaching. Now determine the side distance available to the bicycle if the car is approaching from this side, and there is a building, and the building is 50 meters from the straight line of sight of a bicycle and 35 meters from straight line of sight of a car. So this A value is 50 and this B value is 35. You need to calculate this one. You have this A value and B value. This value is also given. Correct. B is the correct answer. 70 meters. So uh, mm, this there is a car which is approaching this intersection from this side, and there is a bicycle at A which is also approaching this unsignalized intersection. Now there is a building, and because of that, if the bicycle is suppose in this position, they that from that bicycle the car cannot be seen. When this bicycle approached this point, then only this bicycle or the car can see each other, and they will reduce the speed, or they will the bicycle will stop. So there here two triangles are forming. One is A, B and C, one is A, D and E, and we need to calculate the side distance available to the bicycle if the car is at C and approaching the unsignalized intersection. So we need to calculate the side distance for this bicycle, which is dA, that from this point where he first see the car to the point of the this intersection, and this dA distance we need to calculate, and the horizontal distance from A to this building is termed as A, which is 50 meter. Here 50 meter from the straight line of sight of a bicyclist. So this one is A, and a tall building is also located 35 meter from the straight line of a car. So this B is the 35. It is not 40, it is 35. This A and B we know this. So from the similar triangle, this ABC and ADE, ABC and ADE, if we consider these two triangles, so BC by AB, so BC is this total distance, which is 100 meter, and AB is the dA distance which we require to calculate for this triangle ABC, and for ADE the distance is ED, which is A, that is given, and AD, this portion. So we know this portion is B, this portion is B, and the total distance is dA, so it is basically dA minus B, and dB already given as 100 meter. So the car is 100 meter from this intersection. Now if you put the values of A and B, A is 50 meter and B is 35 meter, so the value will of dA will come as 70 meter. So this one will come as 70 meter. So this one is 100 meter, this one is 50 meter, and dA we require to calculate, and this distance is total dA minus 35. 35 is also given, so it will come as 70 meter. Option B will be the correct answer. Next is, based on riding quality, what will be the correct order of choice of pavement surface? Paver block, granite, concrete, asphalt, concrete, paver block, granite, paver block, concrete, or quartzite, asphalt, concrete. Right, B will be the correct answer. So uh, you can straight away actually uh, in this table we have given the what material is desirable and undesirable for developing bicycle facility from different perspective, like riding quality, skid resistance, capital cost, etc. So what will be the correct order of choice of the pavement based on riding quality? Ri Riding quality, asphalt and granite is same, and is most desirable. Then comes concrete, and then comes paver block. So option B will be the correct answer. Next is, which of the following is a regulatory sign? Giveaway sign, cycle parking, cycle crossing, segregated cycle and pedestrian route. The correct answer will be option D. Uh, there are three kinds of sign we have talked about, that regulatory sign, warning sign and informatory sign. Regulatory sign are the sign that needs to be followed by law, otherwise will entail a fine. And then comes warning sign. This signage will cause danger to one's life and may or may not entitle a fine. So by law this there will be a fine if someone is not obeying these signs, and but not obeying this warning sign, there may not be any penalty or uh, any fine, but the people's life may comes into danger. And there are informatory sign, and that is just for the information of the general people and will not entail a fine. So in this case, giveaway sign is basically a sign that mm, like uh, give away to other vehicles, or uh, maybe the vehicles from the major road. So these kind of sign are a warning sign. If someone is not obeying that sign, and uh, they may comes into a danger. So this kind of sign, giveaway sign, is mainly uh, provided where a major road and minor road are actually intersecting. They are for the minor road, this sign is placed so that the minor road vehicle is stop, and they will look for an opportunity. If there is no vehicle or there is a safe passage between the major vehicles from the major road, then they will pass. So it is basically a warning for the users. Then cycle parking or cycle crossing, these are the kind of informatory signs. And segregated cycle and pedestrian route is a regulatory sign. So uh, segregated cycle and pedestrian route is a regulatory sign, and if someone is not obeying, then enforcement authority may fine them. So these signs, they should they must obey, like no parking or compulsory cycle track, kind of the otherwise, like if there are lots of cycle moving in a pedestrian facility, then it may hamper the pedestrians. So if there are separate tracks, then they should go in a separate manner. So option D will be the correct answer here. So that's all from this week. If you have any queries, you can post it in the discussion forum also. And we'll again meet on next Monday. Thank you for joining. If you have any queries, then you can ask, or you may also leave. Question lecture 39 mentioned. Okay, just a minute. This one, right? Okay, let's see what it is saying. Determine the maximum speed which is required for a bicycle to make a safe turn. The radius 30 meter. Utilize. Here it will be 30 meter.
Good afternoon, sir. Good evening, sir.
Good evening.
Solve this problem and I got 2.7, but I don't know how when the 1.17 was got.
This one value, this value.
Yes.
Just let me check. 30 into 9.89. Yes, you are correct. Yeah, the answer will be 2 point something. 2 point. What you have got? 2.1 or 2.7? 2.17, right?
2.718.
718. Yes, that will be answer. I think there are some mistake in this one. Also,
Okay,
also this one will be 30 meter.
okay, that is it.
Mhm. Like
Okay.
this one 30 meter.
Okay, and so I have another question with the comments and the discussion.
What?
Okay, for the comments,
In
for the comment, they said that the speed of the crossing speed of a bicycle along a distance is around 15 to 20 kilometers per hour. But as per the note, is the design speed different from the crossing speed? Because we have 5 to 15 kilometers per hour.
in this
I think, okay, let me find that page.
this one, I think it is
Yes,
in.
yes, 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 that one.
Just let me check once.
Yeah, the first, I think it's the first above the
Uh,
page.
this one.
Yes, 15 design speed. Is it different from the cruising speed?
Yes, it can be different because is there the crossing speed is mentioned somewhere? I think let me just check once. But it can be different from the crossing speed because when people generally cross a particular intersection, so they are not go at a same pace what they are usually go. They generally tend to cross in a hurry or like in a faster actually from the normal speed. So it may be different from the speed they are actually going.
No, it's not crossing, it's cruising. I don't know if it was an error in it.
uh, Cru-
Cruising speed. CRUISIN, cruising.
uh, is there uh, anywhere it is written in these slides?
Yes, at the same bicycle facility where you were design on a design speed. But bicycle facilities on a design speed on the first page for the principles.
This
Yes,
one.
read them. They are saying that the design speed is between 5 to 15 kilometers, important for cyclists to get a cruising speed for a constant. That was the first place this word was mentioned. Then
Okay.
after it was mentioned when you come down for the turning radius. For the turning radius, they said the radius should be less than 10 meters and should be considered as it does not permit cycling to comfortably cruising speed. Yes, right there.
Radius less than 10 meter should not be considered not permit. uh, yes, like minimum designing speed is 12 kilometer. Like when a cruising speed is actually the speed they are moving, and if the radius is very value is very low, then uh, the speed might be higher, and like people cannot take turn with a comfortable manner in a very sharp, if the curve radius is very low and the curve is very sharp. Therefore a radius less than 10 meters should not be considered, because it is not permit cycling at a comfortable cruising speed. So what in general the people are moving in that speed, sometimes it may be difficult to negotiate a curve of less than 10 meter radius. Therefore it should not be provided, and minimum design speed is provided 12 kilometer per hour. So it is between like 5 to 15, and specifically for the for this curve, the minimum design speed is considered.
Yes, but in the question they are considering 15 to 20 kilometers per hour, and as per the note we have 5 to 15 kilometers per hour. I don't know why.
In this one.
No, no, not that. In this numerical problem that is in the notes, numerical one, the solution for the comment and discussion. For the comment, the first line.
Okay, cruising speed of a bicycle on a long ride.
They are saying that it lies between 15 to 20 kilometers per hour, but the cruising speed is 10.
To maintain a safe speed.
5 to 15, I don't know.
Just let me check once. Okay, this is actually in another context, like uh, it is saying that cruising speed of a bicycle on a long distance ride is around 15 to 20 kilometer per hour. So people who are going maybe for joyride, or people who are going a far distance, in that case sometimes people maintain a speed of 15 to 20 kilometer per hour, so which is quite high than the normal speed, which is 5 to 15 kilometer. And but also it is saying that to maintain say 15 kilometer per hour speed, a large radius is required. Means the authority has to provide a large radius for turning of these bicycles, which may not be available on urban roads. Therefore this speed is restricted, maybe considered between 5 to 15 kilometer per hour, but maximum but for the curve the minimum design speed is considered 12 kilometer per hour, because there will be many vehicles which are going maybe a higher speed. So to facilitate those, so that those vehicle can take a safely negotiate that curve. That's why this 12 kilometer, below 12 kilometer, there the speed should not be, like it is the minimum design speed. So below, if although we have a provision of design speed from 5 to 15 kilometer, but if we design a curve for a 5 kilometer per hour design speed, in that case the vehicles which are going at a higher speed, maybe for the long distance bicycles which are going maybe 15 kilometer or 20 kilometer per hour, they may find it difficult. So in no case, for the curb section, the minimum design speed should be to below 12 kilometer per hour. Now in urban context, maintaining the provision can be made, like for if we want to give a better facility, then we can provide considering 15 kilometer or 20 kilometer per hour as the design speed. But in that case, the required radius will be very high, like 922 meter here it is coming. So to get that much of radius in the urban context, it is very much difficult. Therefore the radius is considered around 12 kilometer. That is what actually tried to mean by these comments. Like in normal case it is 5 to 15, that is the design speed. But if we design a particular curve for 5 kilometer, then the vehicles which are at a higher speed, like the long distance bicycles, they may find it difficult. So we also don't want people to find it difficult. So minimum to because there are 15 kilometer per hour is our provision for design speed. So if a person is coming 15 kilometer per hour and suddenly at a sharp turn, they may not be able to negotiate at 15 kilometer per hour. They may reduce the speed, they may have to reduce the speed. Now if in this case, the minimum designing speed for the curve, if not 12, maybe if it is kept in 5 kilometer per hour or 8 kilometer per hour, then it will be very difficult for them to negotiate it. So people who are going at 15 kilometer per hour, they can somewhat easily or somewhat by reducing some speed, they can negotiate this curve with 12 kilometer per hour designing speed. So that's why this speed is quite higher than the normal speed, that is 5 kilometer is here normal design speed, but for the curve it is 12 kilometer per hour. And it is not very high like 15 kilometer or 20 kilometer per hour, because then a very high radius of the curve is required. I hope it's clear.
Yes, sir. It's very clear. Thank you.
Oh. Yeah, sure. You can. Welcome.